All right, so I'm going to say good morning. I don't know what time you're watching this or if you're watching it, but in my town right now it's morning time, so that's what I'm going to say. Today I'm going to talk about Pythagorean Theorem and how you find missing sides using Pythagorean Theorem. The Pythagorean Theorem is called that because Pythagoras allegedly discovered it, he and his weird tribe of crazy people. And the Pythagorean Theorem applies to right triangles. So it can tie in still to the trigonometry that we've been doing, because if you needed to find a missing side in order to set up a ratio, this would be a way to do it. The Pythagorean theorem says if your triangle is right, then legs squared plus legs squared equals hypotenuse squared. And when you're looking at a right triangle, the hypotenuse is always the longest side and the side opposite the 90. And then the legs, because all you're doing is squaring and adding, and that's considered commutative, meaning you could change the numbers, the order of them, then it doesn't matter which one is a leg. Well, it matters which one is a leg, but it doesn't matter which leg is which leg, I guess. There's no feet attached, so you can't tell right from left or anything. So if you wanted, you could think of this as like leg sub 1 and leg sub 2. And there's the first one and there's the second one, but they could be totally flipped and it would be fine. A lot of people memorize it with the letters, so people will think of it as a squared plus b squared equals c squared, where c is the hypotenuse. The only problem with that is if you don't remember that c is the hypotenuse, then a squared plus b squared equals c squared will do nothing for you. So you just want to be careful with that. It's always that the two shorter sides, if you square them and then add them, equals the hypotenuse squared. Now, if we were to do an example of that, we would maybe say find the missing side. And then really, I can put any numbers that I want, because I'm going to use the Pythagorean theorem to find the missing side. So if it comes out as a decimal or it comes out as a fraction or anything like that, that's totally okay, because the Pythagorean theorem is going to help us do that solving. So I don't know, let's say we'll call this one 6, we'll call this one 8, and we'll call this one x. All right. If you were to solve this, my first recommendation would be to go ahead and label the hypotenuse and then label your legs. All right, so labeling the hypotenuse will help you determine which is the hypotenuse, and it'll let you know then that the other two sides are going to be your legs. All right, so my hypotenuse is always opposite my 90. It's always my longest side, and if it doesn't give you a measure, it can be hard to tell that it's the longest side, which is why it's really, really helpful to remember it's always opposite the 90. So this will be my hypotenuse. So technically in this version of the problem, I'm solving for that c. Okay? Then I'm going to go ahead, and it doesn't matter which leg is which. You can call this C, and then you just pick, right? So if you want A to be 6, if you want B to be 6, it doesn't matter, because when you square and add, you can put it in either order and you'll still get the same answer. So I'm going to call my 6A and I'm going to call my 8B, and then I'm going to plug them into the formula. So I know that 6 squared plus 8 squared equals c squared. 6 squared you can do on a calculator, or you can just multiply that, or if you know your squares, super awesome. 6 times 6 is 36. 8 times 8 is 64. And I still have c squared. Now I'm going to take 36 plus 64. I actually picked really well here. This is going to come out nice. My math brain must have decided it wanted nice numbers today. 64 plus 6 is 70, 80, 90, 100. So I have 100 equals c squared. And then you have to get rid of the squared. And the thing opposite a square is a square root. So I know c is the square root of 100, which is 10. Now, it will not always come out to a whole number. In fact, very rarely will it come out to a whole number. All right, in fact, those are so special that they have an entire name called Pythagorean Triples, which is where they follow a pattern, and so they always work. This one actually follows the 3, 4, 5 pattern, which is why it came out to a nice whole number. But I'm going to do a couple more where they don't come out as nicely, so you can see what that looks like. I'm going to do another one where I look for hypotenuse. I'm going to do one where I look for the leg. if you're in my class currently, where we're going to go with this as we are at home for our pandemic is you are actually going to create for me a word problem with the Pythagorean theorem, and you're going to solve it. And I'll actually do a separate video for that so that if you get panicked and are like, I don't know how to create that, I'll help you. All right, so I'm going to go ahead and I'm going to erase this board. And I'm going to do a couple more Pythagorean problems. And sorry, my board doesn't erase great. It's very old. Happens to the best of us. All right, so my black marker's also not working as well as I like it to, so let's go ahead and let's see. Let's say I know that this is 7, this is 12, and that's my unknown. And sometimes there'll just be a question mark there. Sometimes they'll leave it blank if they're feeling sassy. I usually like to label it so you can at least then have a letter to use. If you're like, oh, I don't like the letter because I want to use A, B, and C, then go ahead and replace that letter right away with the letter you like. Sometimes people will use A, B, and C. I don't like to because I like to make you have to think about leg, and hypotenuse. All right, so step 1 again is label the hypotenuse. Remember, the hypotenuse is always the longest side opposite the 90. So this is my hypotenuse. If you hate that x, go ahead and think of it as c. And then for 7 and 12, that's going to be my a and b, and it doesn't matter which one is a and which one is b. In fact, I'll do it both ways so you can see that it doesn't matter. So I'll call this one a to start and this one b. So I'm going to end up with 7 squared plus 12 squared equals c squared. Now, if I did it the other way, what you'll see is those numbers are the same. So it's not going to matter which leg you label A and which leg you label B as long as you label one leg A and one leg B. All right, 7 squared is 49. 12 squared is 144. That equals c squared. 144 plus 49. 144 plus 9 would be 153, 63, 73, 83, 93. Now, I haven't been doing math like that in a long time. So because I don't want you to be ashamed and because it's totally okay to do it, I'm going to double check myself on a calculator. I borrowed this one from school before we got locked out of it. But you can use, your phone. You could use if you actually live in a household that has a calculator, like an actual calculator, you can use that. But it's okay to check this. If you can't do this in your head, there is nothing wrong with that. You're still going to survive and be a totally fine adult human. But just, I'm going to double check myself because sometimes when I haven't done, brain math in a while, I lose it. All right, so 193 was right. I did okay there. Anyway, so now I'm going to say that c is equal to the square root of 193. And if we were working with radicals, like if we were worried about leaving it in radical form, we would do that. We would reduce this if we could. I'm just going to plug it into my calculator. If you have a fancy calculator, the square root is a secondary function. Let's see. I don't know if you could see that. If you don't have a fancy calculator, you have a square root symbol on your phone. I know you do because you all have phones that do this. So just go ahead and find it in decimal. So I get that c is approximately, because I get 13.8924439. I'm just going to say 13 point, I like more than one decimal place, but I'm going to be nice and just say 13.9. Now, why would you want this? Why would this help you? Say you were going to do something in the world where you needed the length of something that was a right triangle, right? Say you were building something, say you wanted to support a corner somewhere and you needed the length. It's really hard to measure from here to here. It's much easier to measure these flat sides and then determine the length of wood that would need to go across that. Now, you probably want to be a little more precise if you were doing wood, just depending on what you were doing. But you're definitely going to use more of a decimal than you are like a fraction or a radical. Now, so check it out. Here is if I do it in the opposite order. Notice I still get the same number. So the order of it is not what matters. You just have to make sure you don't put the hypotenuse on the side that the legs go. All right, so now we're going to do one where I'm going to give you the hypotenuse and we're going to solve for a leg so you can see that the setup's a little different because now we're not adding to solve. We're going to have to do some subtraction. Okay? Okay. So say I know my hypotenuse is 14. Say I know that this side is, 7, and say this side I don't know. Okay? So now I I flipped it around a little bit. I made the triangle look slightly different than we've been looking at. We've mostly been looking at triangles where you have the flat side and then the hypotenuse is this kind of nice piece. Here I kind of sort of flipped it over, but still, the first thing you want to do is label your hypotenuse. The hypotenuse is always the longest side, and if you can't tell what's the longest, it's opposite the 90. Here's my 90, here's my opposite, therefore here's my hypotenuse, here's my C, and this is really, really important. I get students that miss this all the time because you just grab the sides and shove them into the theorem and don't stop and think, well, wait a second, is that a hypotenuse or is that a leg? You just go, oh, it's legs, toss it in there, and you go for it, and then you end up doing the formula wrong. So be really, really careful. Now, these then are my legs. I'm going to go ahead and call this one A, and I'll call this one B. But once again, it doesn't actually matter, and I'll show that to you here as well, which one you call A and which one you call B, because it will still solve the same. Now, this one has a little bit more solving to it because we're going to end up with a numbers on opposite sides, I guess we will say. All right. Leg squared plus leg squared equals hypotenuse squared. My hypotenuse is 14. Notice that 14 is alone on its side. Then I've got 7 squared plus B squared. All right, 7 squared is 49. Oh, let's see, 14 squared. 12 is 144, 13 is 169, this is 196. Sorry, for some reason 14 squared never sticks with me, so I always have to think of it coming up from one I know, which is 12. Anyway, but you can always, of course, use a calculator. That's why they invented them. Somebody was laughing the other day about, like I was in elementary school and they talked about how, oh, well, you're not always going to have a calculator. You're always going to have a calculator until we have some massive event where we don't have phones anymore, I guess. Now, here is the trick with this problem. I need to get this B squared alone. Sorry, that was off topic. I need to move this 49. So what I'm going to do is I'm going to subtract 49 on each side. Okay, so B squared equals 196 minus 49. All right, that might be another one where maybe you can't do that in your head, or maybe you're like me and you haven't had enough wake-up time yet this morning, so you could do it in a calculator. All right, I just did it in a calculator. I get 147. Now I'm going to go ahead and I'm going to I'm going to square root each side. So I get B equals the square root of 147, and I'm just going to go ahead and plug that into my calculator. And that gives me 12.124 with a whole bunch more stuff after it. So I'm going to do that. 12.12 is what I'm going to call it. Now, a couple of things here. When you are solving Pythagorean theorem, you always want to stop for a second and go, oh, wait a second, does that make sense? Now, what side should be my longest? This one. So if I solve this problem, and for some reason this number ended up bigger because I had the problem set up incorrectly, that I put 14 on this side, and all of a sudden my leg is larger than my hypotenuse, I know that I've made a mistake. So one quick way to check that you are on at least the right track, whether your math is right or not, is did the number that I get make sense in the triangle? If I'm looking for the hypotenuse, is it larger than the other two pieces? If I'm looking for a side, is it smaller than the hypotenuse? And this one's smaller than the hypotenuse, so it works. I said I was going to try this one in the other order, so say now I have a squared plus 7 squared equals 14 squared. So notice now what I've done is I've flipped the unknown and the 7. I still get, though, the same answer. All right, so that's why I was saying when you pick the legs, when you identify which leg is A and which leg is B, it doesn't make a difference. The only thing you have to make sure you always put it in the right spot and you always label it correctly is the hypotenuse. All right, so this is just a general how to solve Pythagorean, because your assignment for the week is going to be to create a word problem for Pythagorean theorem, which I'll do a video on, and then to solve it and show me how you solve it. So this just gives you like a reminder if you haven't solved Pythagorean in a while. All right, I hope you have a great day, and I will talk to you later. Don't forget, if you have questions, come to my office hours, send me a message, send me a remind, send me an email. It's insane that we can't see each other, but we have to do what we can. All right, talk to you guys later. Bye.